If you need to spread out the chairs, Paul's son set them up today, so they might be a little bit close to one another. Feel free to get yourself comfortable. All right, welcome to the August Bitcoin and Open Blockchain meetup. It's great to see familiar faces and new faces. Welcome, welcome. I have a couple announcements. First of all, we are doing a giveaway of 7 ZEC today. So I passed out cards with numbers on them. Those are your tickets to enter. You do have to be present at the end of the meetup to receive your ZEC. I would recommend, if you don't have a wallet, to go ahead and download one. I would highly recommend the Edge wallet, clearly. And something else I would recommend is to make sure your wallet is up to date and fully synced, so that at the end of the meetup, when I send you your ZEC, you'll see it in your account. But we can chat about that after the event. So, yeah. The other thing is I want to just shout out our sponsors really quick. We have Coinstructive. They will help you with all of your crypto scams that you hopefully will never run into. But if you do, we know who to send you to. Chris here, he's with Coinstructive, and he's a great crypto PI. Edge as well, of course, we're the venue, so super happy to have you all. We're a multi-asset self-custody exchange platform, so you can buy, sell, hodl, stake, all while holding your own keys with Edge. And we also have Bitrefill as one of our sponsors. They're our main sponsor, actually. So if you're enjoying beer and pizza, you can go ahead and thank Bitrefill. They're awesome. I would definitely recommend using them. You can use them inside your Edge wallet. Isn't that nifty? Other than that, Zcash is also sponsoring. I've got my Zcash shirt on. I did also want to say we have a Zcash meetup here in San Diego, and I would love for you all to join. At our Zcash meetups, I kind of do crazy events. So we've done ice cream socials, we've done pottery nights, we've done bonfires. I kind of like to switch it up for the Zcash events. The Bob event is awesome. This is the OG though. We have 2 awesome speakers for you tonight. Bogdan is going to be discussing zero-knowledge proof technology, and he's going to prove to you that you don't need to be a developer to understand this technology. It's for everyone, and there's tons of use cases. And Sam Holmes, he is one of the engineers at Edge, so he's going to be chatting about Bitcoin Ordinals. And we're going to have a quick Q&A right afterwards. We are live on YouTube as well. So hello, YouTube people. Yeah, we'll go ahead and get started. Bogdan, take it away.
How do you make
Okay, doing handheld? Okay.
Okay, so yeah, definitely you can hear me now. My name is Bogdan. It's Bogdan. I'm from Ukraine. I moved to USA like 3 months ago So I'm based here in San Diego right now, but originally I work for a Ukrainian blockchain development company. So I'm a business development guy. And I'm not a technical guy, which is one of the primary reasons I'm about to give the topic which I'm about to give, which is about the zero knowledge proof technology. Can you raise hands who have heard about it? Okay, so quite many people actually. And who thinks he has some idea on what it is? I'm not gonna challenge or test or something, but anyway. Okay, so yeah, I know about this technology. I have pretty good idea about what it is, but I'm not a technical person. So, I found it really hard to grasp this technology being a non-engineer or a non-cryptographer. And right now, like I was in Portland last week, and literally every second talk was about zero knowledge proofs. So it's really, really like popular one right now. And so yeah, I already spoiled my meme, but essentially that's me in every zero knowledge proof discussion, and I see this problem very often. So you go starting from the high point where you can understand the generic definition of zero knowledge, but then when you try to really understand, like, you know, the applications and stuff, basically you delve deeper into this alien language. So that's why it's really tough, because if you're not a cryptographer, it's tough to understand it. A couple of disclaimers so that I feel safe talking about what I'm about to tell. I'm not an engineer, so I'm gonna talk about like the whys and not the hows. I cannot explain how exactly this mathematical circuits in zero knowledge proofs work. If you are an engineer and you see bullshit, that's possible. So just let me know. I won't be too defensive. So yeah, let me know. A lot of things we're about to discuss are more theoretical rather than practical. And I could sound a bit speculative, but that's mostly to make it a little bit entertaining and just to get some of your attention. So yeah, the problem with zero knowledge proofs is that the definition is generic, but it's alien language when you try to delve deeper. And that's like an example of a dialogue between Alice and Bob. In this dialogue, I'm an Alice. I was Alice before I kind of spent some time researching this technology. So you're asking somebody like, what zero knowledge proofs? And they tell you this definition. If you Google, you will see mostly this. Like, it's a technology that allows you to prove the fact of the statement without revealing the statement itself. So, and that makes you think that it's somehow related to kind of privacy that's achieved through cryptography. But then when you like research, deeper, it turns out that there are also snarks, starks, rollups, zk EVM, and they kind of they don't really solve privacy, but rather scalability. But the definition still stays the same, and so you're like, confused. There are a lot of examples about zero knowledge proofs about like Sherlock Holmes who proves to Watson, who is colorblind, the color of the ball. Or something like that, and it's kind of creepy. You don't understand what it means. Just a quick joke before we move further. That's AI-generated picture of Sherlock Holmes and Alibaba. It's also another example of that people use to describe zero-knowledge proofs. Yeah, Alibaba and Sherlock Holmes not revealing their secrets. It's AI-generated this thing. So, okay, now to the specifics. So, zero-knowledge proofs, they solve two problems. It's either and or, privacy and scalability. So, when you hear about any use cases, you should think that it's probably one of them. Sometimes both, but usually just one of them. Let's start with privacy because it's just easier to understand. In fact, I think that scalability is much more interesting, and that's specifically the reason zero-knowledge proofs became really popular these days. So very easy example and very interesting one, it's like age verification. So basically, if you can imagine some online website or service or an app like Uber or Lyft or whatever, and you have to prove that you're, for example, higher than 18 years old, your age is more than 18 years old, but you don't want to tell exact age, then that's a use case where zero-knowledge proofs can help you do that. And that's really interesting. So, because Lyft, for example, as I know in California, you cannot drive a cab if you're below 18. And that's why Lyft started to ask, at a certain point in time, Lyft started to ask users like their age. and some people are not happy about it. So ZK could help you solve this problem. Another like 2 examples, and again, it's theoretical. This is just for you to have some construction in mind to grasp all the potential use cases. So whitelisting is, if you imagine like, again, you have a list of addresses or users who can do something, for example, go to this meetup or use some online service, and you want to prove that you're on the list, but you don't want to tell exactly who from the list you are. And so that's another example where zero-knowledge proof can help. And another one, this is really interesting, which is anonymous reporting. And I have a good example of how somebody actually implemented this in real life. It's this Curia app. I met this guy on the event in Frankfurt in Germany. And so what they do is they implement zero-knowledge proofs in healthcare industry. And the idea is that the platform is intended for people who have incurable disease or hardly curable disease, such as cancer. And they provide reports about how their disease goes. And then researchers, they kind of research this report, but it's anonymized. But zero-knowledge proofs allow you to prove that this report actually goes from certain patient, and it's not just some random report. It actually goes from a patient. Yeah. So another really interesting topic before we delve deeper into scalability is zero-knowledge proofs and AI. So I was reading an article some time ago, which was saying that zero-knowledge proofs will allow you to verify the API that you consume and AI models which you talk to. So, for example, you all heard about ChatGPT, and imagine you paid for ChatGPT 4, and you want to ensure when you talk to it that you actually talk to ChatGPT 4 and not ChatGPT 3. So right now, the only way how you can ensure this is you see on the website that it says, okay, now you talk to ChatGPT 4. But essentially, that doesn't give you guarantees that what you consume is ChatGPT 4. And zero-knowledge proofs can give you guarantees about that. And that brings us a little bit closer to the scalability topic. So actually, this article, it then speculates on a much more general idea that zero-knowledge proofs can allow you to verify all the kinds of APIs that you consume, any data or logic you consume through APIs. So basically, and that made me think that Web 3 without zero-knowledge proofs is something like Web 2 without HTTPS. So right now, if you go to any website, everybody uses HTTPS, and it's just a poor tone not to use it. So maybe this is like a speculative idea that I had in mind, that maybe in 5-10 years from now, every online service that has APIs and provides some service to users, they maybe will use zero-knowledge proofs. Now, regarding scalability, so why are we actually talking about this? You always have this trilemma between scalability, security, and decentralization. Basically, not like it's a very popular idea in Web3 that we should decentralize the whole world. Corporations are killing us, so they're centralized, and we should be all decentralized. And it's a nice idea from philosophical perspective, but from tech perspective, decentralizing everything doesn't make sense. So some pieces you are decentralizing, and in some pieces you don't do that. And that's why it's just important to understand. And there are many ways how you solve this problem. So I just want to focus on the idea that decentralization, it's my opinion, my personal, that decentralization is not really the must-have of Web3. It's a nice-to-have in many cases. But what's a must-have? It's a data provenance. And data provenance is the fact that you can prove and guarantee for yourself that the data that you consume is authentic, that it's not being changed by somebody, and you can trust this data. And so why am I describing this right now is because zero-knowledge proofs is specifically the technology that allows you to kind of achieve this even in a centralized environment. And that's really a very interesting idea. Mm. So this is like evolution of solving scalability in the blockchain space. But before we go through L1, L2, optimistic rollups, etc., there's words such as rollups, ZK, EVM. So I just want to give you a little bit of background about this so that you understand what it is and how it's related to each other. So zero knowledge proofs is the general one, the blue one. It's a set of technologies which we're discussing right now. ZK Starks and Snarks, now we're narrowing it down, and this is like another set of technologies which is used kind of for the same purpose, but it does it in a more efficient, in a fast way. I don't want to delve deeper because I'm not an engineer again, and that's not like the topic, but I just want you to understand the relationships between those terms. So just remember for now that ZK Starks and Snarks is just a faster, more efficient way to do this. Next thing is rollups. Zero knowledge rollups are essentially layer 2 blockchains, the goal of which is to scale L1, layer 1 blockchains, the main blockchains such as Ethereum. And it's important to know that not all rollups use zero knowledge proofs. Some do, and those that do, they use zero knowledge Starks and Snarks. I know it's kind of a little bit complicated if that's the first time when you see it, but it's fine. And then you have ZK EVM, which is also a rollup, but it's EVM, it's compatible with Ethereum virtual machine. So for now, I understand that maybe more questions than answers, but for now, just keep this in your mind. Now let's delve into how the evolution of solving scalability in blockchain. So basically, I guess everybody knows here what is blockchain. It's a decentralized database, and what it does, it validates transactions and it records transactions on itself. So the first thing that people were doing is they were validating and recording transactions on L1, like Ethereum, for example. And it's good. It's really secure. It's badass secure. But it's slow. It's slow because the demand is higher than the supply. Like in market of searching apartments of San Diego. So L1 is San Diego. I've been searching apartments for 3 months, and it's still expensive. So when you don't have you don't have enough capacities to serve, like in San Diego, and it starts to get expensive, people came up with the idea of L2. So L2 is a separate blockchain that does the same thing, but it's it's off-chain, off the L1 chain. And it's faster because you no longer spend resources of main Ethereum blockchain, but it's less secure. Then the next step was another L2. Optimistic rollup is also an L2, but basically it's fast, it's better secure, but optimistically better secure. So, and the idea of optimistic rollups is that now people say, okay, we're gonna record transactions on L1, but we don't want to spend all our resources verifying the correctness of each transaction. The correctness of transaction means that I don't spend money which I don't have. So if I send 500 USDT to Sam, I have to have them. Otherwise, it would be an incorrect transaction, and somebody should verify that. And so with optimistic rollups, from the concept perspective, how it essentially works is that there are let's call them users who upload this set of transactions into L1, and they're optimistically considered correct. But then there is a certain set of validators who challenge randomly some transactions. So analogy to understand the whole concept is basically how tax system in the US works. Nobody monitors every single person, but if they will, look at you and you don't pay taxes, you're gonna be fined at least, or you will go to jail. So the same thing here, you randomly just challenge some transactions. If somebody uploaded the wrong one, they will be fined. And they have a stake that they put for, So it's really very smart decision. It's fast, but obviously it has its security assumptions. Now ZK rollups, and this is now we're finally going to how zero-knowledge proof solves scalability problem. So they are, and that's really sounds like magic. They are fast and they are better secure, all basically without assumptions, and that's really interesting. So it sounds like magic. It sounds like, and this is the reason why it's very popular technology. Like we almost don't spend L1's computational resources, meaning that L1 doesn't verify every single transaction on correctness, which is good. But at the same time, we ensure that transactions kind of are correct and are backed by security of L1. Just for you to understand how crazy this is, it's like another example is if somebody would come up to you and say that he has invented a political structure which is as qualitative in decision making as democracy, but it's fast in its speed as totalitarianism, which is obviously impossible. But the thing is that in crypto, with cryptography and mathematics, you can actually combine this, and that's like really sounds like magic. So although I cannot tell you how exactly it works, because again, I'm not a cryptographer, but I know that there are a lot of people in this space just like me, but they still have to understand something. Like I was talking a lot with my colleagues, cryptographers. They are already tired of me because I was asking many questions, and so I'm just trying to save a little bit of your time if you didn't yet research this technology. So this is like example which can help you comprehend how zero-knowledge proofs actually do this magic. So imagine you have certain method. Every program is basically a method. You have input, then method does something, and then you have output. So imagine the method basically, it takes, certain set of numbers and it has to provide the average number among them, which is, easy, very easy task to do. So you just sum up, 2, 1, 3, and then you divide them by their number, and then you receive the, the average number. So imagine you have to, and there's a method that does that. So you provide the input and then you expect some output. Imagine you have to ensure that the output is correct, but with two assumptions. So the first assumption, you don't want to spend your own brain resources to analyze the correctness of the method, meaning you don't want to in your mind sum up 2 plus 1 plus 3, divide by 3. So you don't want to spend time on this. Obviously with this method it's kind of easy, but if we consider bigger methods, it's kind of hard. And the second thing, you don't want to audit the code every time you call the code. So, and zero-knowledge proofs actually, what they prove is that the output has indeed been generated using the method, and that the output is actually based on the input. And so these three things, they're kind of glued together, and you have a guarantee that the output is actually the result of working of the method based on the input. So under the assumption that you have audited the code just once, because you have to trust that it works, you can guarantee that the result will be correct. So now I just want to pause here for a second to describe what it actually means and why it's so revolutionary. 5 minutes. Okay, got it. It's already the end because it's the cornerstone. So it's extremely important to understand. You ensure authenticity of certain logic, but without L1 smart contracts, outside of decentralized environment, and outside of consensus. Not spending L1's resources almost, because L1 still spends some resources to verify the validity proofs, which are generated by zero-knowledge proofs, but that's not too much. So that's really important thing, because before that, basically the only tool how humanity has, I think, figured out how to ensure authenticity of some digital data or logic was basically through consensus, through decentralization, because because it's decentralized, meaning it's secure. So if 51% is trustworthy, then you know that your audit is not backdated, it's the same that you actually deployed, and then you can trust the results. But here, you can do that outside of consensus, and that's really like very huge idea, I think. And I think that people still don't underestimate how big it is in terms of architecture of the future system. So again, very fast, like in my example of brain, like brain doesn't want to double check the result of the method. L1 doesn't want to audit every account, like, verify every transaction. Brain doesn't want to audit the code every time. L1 doesn't need to store the smart contracts with certain logic on itself to prove that it's correct. So in future, I think, I know that's the whole presentation has a silly design, but I think it doesn't really matter. In future, I think that probably, that's also a speculative idea that I have in mind, that any system that will, do some API, it will have to use zero-knowledge proofs, because I think that will be a poor tone not to use it, because that's the only way how users can actually prove, how you as a service can prove to users that what they consume is actually what you tell them they consume. Yeah, and it's outside of decentralized environment. I think that's it.
All right. Do we have any questions for our speaker?
Now let's go to the second slide, disclaimers. I'm glad I put
Bogdan,
it. Thank you. I'm glad. I mean, I spent those 1 minute of my time.
If you don't mind telling us a little bit about who you work for and how to stay connected to you outside of the event.
I forgot to input this information in the slide. So I work for Distributed Lab. It's a blockchain R&D center, fully based in Ukraine. We are 100 people, around 70 engineers, cryptographers, around 70 tech people, and about 30 guys like me who do business development, marketing, and stuff like that. So the whole team is based in Ukraine. I'm here. I do business development. So basically, I guess I will send my contacts in the chat or something, or you can just come up to me, and I would be happy to talk to you and exchange contacts.
I've got his LinkedIn profile linked in the event description as well. So
also, this presentation is based on the article I wrote on Medium, so I can share the article link to the chat.
All right, any questions? We got a question over here.
Could this, sorry, it's really loud. Since you mentioned AI stuff and like people can create like deep fake stuff, could this possibly be used to be able to prove like the source of where like a piece of content came from? So
I think so, yes. So as long as you have digital identity assigned to like AI or something, and it will be, you have to assign certain digital identity to AI, and it should be glued to the result that it provided. In this way, if somebody provides a deep fake, if it doesn't have a digital identity assigned, then you know that it's could be a deep fake. So I think under the assumption that you have to, everybody have to assign this digital identity, yes.
Alrighty. Any other questions? We got one right here.
Can you apply zero-knowledge proofs to other areas of like Web 2 for provenance?
Yeah, so the best example is the one which I mentioned here. It's completely Web 2 stuff, really. It's basically a system, it's a platform that connects patients. So they are actually like somehow connected to hospitals today. It's not just like fancy startup idea that they pitch. They are actually doing this today. It's a platform that connects to patients who have cancer disease or something like that. The CEO actually came up with this idea after his uncle died from cancer. And the doctors told him that we could have saved him if we had more specific information. But then he like, okay, but why do people don't provide this information? And then he found out that people are just hesitant to do that because for privacy matters. So you don't share this such a critical information with third party, nobody. And so this is a completely Web 2 stuff where he actually connects with those patients that provide the reports. But still, for researchers to actually base their medicine results on reports, they have to trust that these reports are authentic. That's why you have to have zero knowledge proof. That's why just erasing the name out of the report wouldn't help, because researchers have to have guarantees that this report is actually coming from somebody.
All right, we got one more question over here.
Correct me if I'm wrong, but it sounds like zero knowledge proof would be replacing like proof of work or like proof of stake, for example. So what would be the main difference between like zero knowledge proof, between proof of stake and proof of work in a coin or a token?
So they are not replacing, because proof of work is consensus mechanism, and again, so consensus mechanism will always have its applications, and zero knowledge proofs is not a consensus. It's not used to, achieve consensus between people who don't trust each other. You use it for a different goal. So they wouldn't replace consensus. Yes. So basically, this is my idea on how they could work together. And basically, what happens right now is with ZK rollups, they already work together. So when I say work together, it means that you have zero knowledge proof L2, which verifies that transactions are correct, and it gives definite proof to L1, which has the consensus which you mentioned. And this result is being written on L1, so they kind of work together in this example. You have to have consensus to have decentralization, so there's no way consensus would go anywhere. We still need decentralization, but just not everywhere.
Okay, we're going to do one more question, then we're going to hop over to our next speaker.
Two very short related questions. Could this be used for whitelisting something as simple as an email address as not a source of spam? And related to that, could it be used to verify that a particular entity holds a certain amount of some asset?
For sure, yes, especially the second one. As to the first one, it's just I need to kind of figure out how organizationally it works, because I don't know how to implement zero knowledge proofs into emails, directly. But in crypto wallets, I guess there are already many examples of, I don't know exactly the ones which I can share, but I'm pretty sure there are where you prove that you have certain balance while not sharing exact balance that you have. So meaning you want to prove that you're above some threshold.
All right, let's give it up for our speaker.
Thank you very much. Thank you for listening.
All right, as we switch over, I just wanted to, first of all, thank our volunteer over here. We've got Andrew on the audio visual. If you want to get involved, we are always looking for help. If you know someone who wants to speak, or if you want to help set up, take down, if you've got a skill that you'd like to share with us, contact me and we can get you involved somehow. Both of our speakers tonight are from this community, and so that's super special. It's an honor to have people on this stage who are, a part of our community. So don't hesitate to reach out and we can work something out. So next up we have Sam Holmes. He works at Edge. He's a senior software engineer. He's going to introduce himself, but super happy to have him here. Also, remember to have a fully synced Zcash wallet ready to go. Fully synced. Key on the fully synced. There you go. Is that one mine? Mine was over there. Was it on the table? Yes. Oh, okay, I think that was mine. All right, Sam, take it away.
Okay. Oh, you're good. I'll give it a try. This is another one. We'll see. Okay. Can everyone hear me? There we go. Cool.
I'm gonna go get a new one, actually. This one's empty.
Okay. 1 second while I get it set up here. Let's go ahead and move that over here. There we go. All right. Good evening, everyone. All right, so a little loud, all right. Probably a little bit lower. Okay, can everyone hear me okay? Yeah. Cool, cool. All right, so my talk titled Ordinary Bitcoin. It's about Bitcoin Ordinals, Inscriptions, and BRC20s. Who here has heard of Ordinals? Okay, quite a few. All right. So yeah, I'm going to be exploring that topic and a little bit about me. Hello, Samuel Holmes. I'm one of the senior software engineers here at Edge. I joined in about late 2020. I wear many hats at Edge, doing various things, but one of the more noteworthy things was I led the new Bitcoin plugin development for Edge app. And I'm an enthusiast when it comes to Bitcoin, peer-to-peer technologies, as well as web technologies. And even more recently, a dog dad. So that's Bruce, my dog. So yeah, that's a little bit about me. All right, so getting into the talk, what are Bitcoin ordinals? So ordinals are, you can think of those as serial numbers, like, you know, the serial numbers you see on dollar bill, right? For each Satoshi unit. Satoshis are not Bitcoins. They're the atomic native unit currency. I'm sure some of you may know this, but for those who don't, a single Bitcoin can be subdivided into 100 million Satoshis. So that means the 21 million Bitcoin cap is actually 2.1 quadrillion Satoshis. So yeah, from the theory handbook, the individual sats can be inscribed with arbitrary content by having these Bitcoin or serial numbers, and then they can be transferred from wallet to wallet. So it kind of allows you to do these non-fungible properties. So how they began, they were developed by this gentleman here, Casey Rodarmer. I'm hopefully not botching his name. He launched the Bitcoin, he launched this protocol or theory on Bitcoin mainnet in 2023, this year. His motivation was to enable NFTs on Bitcoin, mainly because he was dissatisfied with the Ethereum NFTs due to their complexity, some of the security properties. Him being I think a core contributor, Bitcoin developer, wanted to dabble in NFTs, but was not happy about some of the landscape there. So he dubbed it ordinal theory, but in my opinion, I would consider this a protocol, or at least a pseudo protocol. Essentially, it's an idea of overlaying metadata onto Bitcoin's blockchain that already exists. Inscriptions, on the other hand, are the arbitrary data assigned to each ordinal number, giving those Satoshis the non-fungible properties. Again, this requires no change in the Bitcoin protocol. This is all just metadata and theory on top of Bitcoin. So I'll go into a little bit how they work. So some of the theory. Ordinals are congruent to the concept of ordinal numbers in set theory. So it's kind of a mathematical term that he borrowed. Perfectly nowhere else in a Bitcoin landscape was that term used, so that was nice. They are static, unique identifiers for each and every Satoshi unit. I know I keep saying that, but it's important. And they're assigned based on when the sat was mined. So the first block, Genesis block, has 50 Bitcoin, which is, if my math is correct, 5 million Satoshis. Those get the ordinal numbers 0 to 5 million, right? Second block, Genesis block, will then continue that count up. Here's an example of the second block, block 1, because of we order based on 0, block 0 being the first. I couldn't get block 0 to open in this Explorer for some reason. It kept erroring, so here's block 1. This is looks like a lot of technical stuff, but I'll point out the main points here. Here's one transaction, which is actually the payment of Coinbase, new Bitcoin issued to the miner. If we open up that transaction, you can see in there, this is a fake input. There is really no one transferring the Bitcoin. This is new Bitcoin created. And here's the output of that transaction. Can everyone see that okay? Okay, zoom in a little bit more. So here's the output. And you can see the value of this output going to the miner is 5 million, if I got that right. If you then look at that output, you can see that inside of this output, it hasn't been spent, I don't believe. There is the Satoshi range of 5 million to, I believe, 10 million or so, or 100 million, can't remember. But this is the ordinal numbers assigned to each of those 5 million Satoshis. So you can click on that, you see the first one, click on that, you can see information about that ordinal Satoshi, that single Satoshi, and the ordinal number and whatnot. So that's that. This makes sense so far. If anyone has any questions, feel free to kind of delve in. Oh, that looks a lot better. Perfect. So as I mentioned, to transfer these ordinals leverage the existing transfer mechanisms of Bitcoin without the need for any soft fork. So that means that there was no developers that had to like activate any change to the Bitcoin network. It just works automatically without any change. A Satoshi ordinal number is carried with it from the previous transaction to the new transaction's output. So if I have an ordinal number 123 and I send it to you by sending you a transaction with a Satoshi that has that ordinal number, you then are by ownership of that Satoshi, you have that Satoshi with that ordinal number. So here's like a little graph of kind of how that would work. If you see on the left here, you have all the inputs for your transaction, all the coins that you have. Say I have about 29 or 30 coins, I think 29 coins on there, that have the ordinal numbers 1 through 29. And then I have another input here with about 6 Satoshi units from ordinal number 100 to 106, etc. And then down there you note that I have a smaller Satoshi ordinal number. And I send those to someone else or maybe multiple people. The distribution of those ordinals get distribution by like the order in which the inputs are. So you can see that the first ordinal Satoshi here with ordinal 1 gets sent to there, and number 2, etc. So that kind of hopefully that makes sense. Do note at the end here, these 2 inputs on the left, at the bottom, get sent to a single output, and they get all the ordinal numbers in that single output there. They get kind of combined, and then it can then be sent and broken apart that way later on. So that's how transfer works. So again, just using regular Bitcoin. So this is a bit of code. I don't expect anyone really to understand this, but I want to just illustrate that the implementation for ordinals was so simple that you can literally fit it within one page here. If anyone knows Python, then feel free to read. But I just wanted to illustrate that the algorithm isn't complex, and that's possibly why it was so easily adopted, or a lot of people did adopt it. Okay. All right, so that's ordinals. How do inscriptions work? So as mentioned previously, inscriptions are a way to put a significant amount of data on chain. Previously, you were very much limited to how much data you could put on chain. Op returns and things like that. But when Casey Rotemer discovered that, invented this way with inscriptions, you can put upwards to 4 megabytes of arbitrary data that is the maximum block size, can be stored on chain within a single transaction. So technically a single transaction could fill up the whole block, I believe, if not multiple transactions. You can fill it up. This allows for things like images, text, GIFs, HTML, and more other content types can be stored on chain. This was enabled by a hack made possible by the introduction of Taproot. I'm sure you guys heard of that term thrown around, but specifically TapScript, which came along with Taproot. Here's a little chart of what has happened since inscriptions were launched on mainnet. Okay, it's not working. Let's see here. One more time. Nice. Spaces refuse to connect. I'll just do that. So here's a chart. When this launched with inscriptions, people started putting a lot of content on chain, and that increased the block fees from upwards to $120,000 at the peak in fees. So yeah, there was a bit of a block congestion there. Since then has died down. But you can see how people were kind of excited, and that excitement did dwindle off. But later on, you'll see how there's still trends in which this use is still going on. All right, so let's go back. Hopefully. All right, here. So again, a little bit more technical, but I wanted to illustrate, if for those who are interested, how inscription data was embedded within the transactions. This is the hack. It is pretty straightforward. Essentially, the op false set at the top is basically the condition that we're checking. Following that op false, we say if the above condition is true, then do the things below. Obviously, false is not true, so we're never doing the things below. And so we skip all that block of code below, and the op end if is the end of our operation. This allows us to embed data that doesn't get run inside the script. And the data that we put in there is the content itself, which wouldn't affect the transaction at all, but allows us to put a vast amounts of these op pushing of data. We can only put for each op push of data up to 520 bytes, which is why there's multiple op pushes that in aggregate can be a full image, page, etc. So I'll give you a little example of that. Hopefully it works. It's not working. All right, let's try it again. So here is a transaction that I wanted to illustrate on chain that contains all that data. So you can see here's all the data in hex. It doesn't look like anything. Here's those actual the script, and you can see there's multiple op pushes, and it goes on and on and on and on. And this itself looks like a lot of data from text, but in fact, that here is this transaction, this ordinal of, I think, Nick Cage on a pizza. I don't really know, but yeah. So someone put this on chain, and that's great use of the blockchain space, I would say, definitely. So we can click into this output. We can see. Let's see if we can find this inscription. Whoop. Not sure how to get to the inscription itself, the ordinal itself, but there's an ordinal number associated with this inscription that then could get transferred. I think if I go to output here and then here, no, did not work. But yeah. Back. Okay. So later on in March, I believe, of this year, after Ordinals and Inscriptions was announced and people were minting NFTs like crazy, monkeys, pizzas, whatever, this guy by the name of Domo Data on Twitter came up with this concept, very experimental concept of putting tokens on Bitcoin's blockchain. So the way he thought about conceptualizing this was he uses a JSON code format where he's inscribing this text that defines the token, and it was proposed as experimental, right? And not to be used for any serious purposes. These JSON formatted scheme is a way of inscribing operations or function calls to do deploys, mints, and transfers of tokens. I would consider these like fungible, non-fungibles. I don't know. So I'm going to go into a little bit how that works. but I'm going to kind of go as quickly as possible. First of all, before you can even create a token, you have to first deploy it. Deployments are initialized using this JSON on the right. The first deployment, it actually defines a particular ticker symbol. You see tick over there saying ordi, that's the ticker symbol. The max supply of that, and then the limit, I believe the limit of how much you can mint per user. So that's step one. Step two is then to start minting those tokens. Mints provide a balance to only the first owner of that inscription. So if I inscribe this, I only mint to myself. If I transfer that inscription, it doesn't mint to anyone else. Transferring it doesn't affect other people's balance state. Following that, I can then inscribe, once I have minted some token and I have a balance, I can inscribe transfer inscriptions. And I can then send those, once received, if valid, send those to other people and to a desired location, and therefore transferring that amount that I have out. So transfers deduct from the sender's balance to the receiver's balance only upon the first transfer. Later transfers of that function will only, I believe, they cannot be retransferred again. You have to inscribe another transfer. Okay. So here's a bit of an illustration of how that works. So at the top, we have the balance going to the minter, because at the bottom we have an inscription that the minter inscribed. So that's that text that was inscribed to mint. And then on the right, here's the action to transfer. The sender then inscribes a transfer text inscription and then sends that ordinal to a receiver in step two. By sending to the receiver then gets a balance in that token. Pretty straightforward. Very experimental, yes. Despite ordinals and BRC20s being presented as experimental, I believe it's received considerable reception from the market, and even some dedicated exchanges for NFTs and BRC20 tokens. So I just wanted to show a little bit of analysis here, but this isn't working either. So let's just go this way. One thing that I thought was very interesting was these ordinal total fees, 4 million, and again you can see that spike in the beginning. One thing I just really wanted to point out, I think it was on this chart here, was oh, it wasn't this chart. Next one, sorry. Changed a bit. Changed from last I put this on there. They might have changed it. But I'll share this slide so that way you can digest this data. It was a chart showing the curve in which the growth was happening and continuing on. But yeah. We'll skip that for now since we're running out of time. Yeah, what the heck? All right, so this is CoinGecko. You can see all the tokens here listed. Market caps and things like that. The volume in which Ordi, the first token inscription, 24-hour volume, we're still at like 16 million. So it's a growing market. There's still activity. Obviously, there's that peak in the beginning, but slowly died down, but still trudging along. I wish I could show you the actual chart that I had, but it's not showing up right now. So yeah, in conclusion, ordinals enabled Satoshis have this numismatic property outside the exchange rate. They can have this non-fungible value of art, or they can be fungible like tokens. Ordinals kind of, to me, illustrate a breakdown of like the objectivity of what digital currencies are. Like, is one sat worth, a fraction of a dollar or a penny, or is it worth $1 if it has inscribed to it a stable coin, right? That becomes a little unclear now. and what happens when its worth in Bitcoin goes up above beyond the worth in the stablecoin. So it kind of makes things a little less clear, but kind of breaking things is good in my opinion. So we're still early, but we'll see if this is a fad or if this will ignite a new sort of decentralized market on Bitcoin. That is it. Oh, shoot. We're not even following. I apologize. Yeah, that was conclusion. Any questions? Here's some information to learn more, and that's it. That's my talk. I take it we don't have time for questions.
Yeah, we can
do?
take some questions.
Okay, cool.
Yeah. Any questions for Sam? Go on right here.
Does the ordinal get assigned to the newly, mined, bitcoins, or what happens to the existing bitcoin which are in the circulation now?
I'm sorry, can you say that one more time? Oh.
Yeah, the ordinal number, the sequence number you mentioned, get assigned to the newly mined,
It's actually,
or already assigned to the existing?
it's so the way it works is it's not necessarily anyone assigning these ordinal numbers to Bitcoin, but someone retroactively looking at every Bitcoin and counting them and assigning them a number by the order in which they were mined. So the first Bitcoin ever mined gets ordinal numbers. They just give a specific identifier and track that as it moves along in the blockchain.
Is that applied already?
Yes. Yeah.
Okay, thank you.
Any other questions? Got one back here. Wait one sec.
So just for clarification on that, there's no actual data stored with the SAT. It's just a history of where that SAT moved from its original position. Is that correct?
Yes. So for the ordinal itself, which is the number assigned or tracking that Satoshi, there's no data associated with it by default. The inscription part, which shows that taproot hack that I showed, was a way in which people can put data on chain. And by putting data on chain, the protocol then says, okay, whatever Satoshi was used for that particular inscription now is assigned that data, and the transfer of that Satoshi is considered the transfer of that ownership of that data.
Is it safe to assume that the BRC20s, they are really only using inscriptions, and the transfer of the tokens has nothing to do with like the individual ordinals?
Yeah.
Is that right?
Yeah, so the Domo Data on Twitter, for whatever his name is, came up with the idea of, well, what if we inscribe these sort of like functions, right? And they're just data on chain. And then the inscription you can transfer, and you can transfer that inscription to another person. And then we can then translate what is the final outcome of the state for that person's balance, let's say. So yeah, it's just using text inscriptions on chain, and the transfer of those can mean certain things under the case of like the transfer inscription, but for the case of like the mint inscription, transfer of that inscription does nothing, right? Other than to the person that inscribed it. So yeah, does that make sense?
Yeah, as a quick extension, there was some criticism that BRC20s were very inefficient relative to some other token protocols. Would you be able to share what made them so inefficient relative to some of the previous protocols? Do you happen to have covered that?
I don't know of too many other protocols other than things like counterparty, right? The difference with counterparty and I would say the inefficiencies there is that with counterparty you just put on chain some function calls that change the state, whereas this you would put a lot more data, JSON data on chain to then do the transfer versus like a compressed version of it. But then the transfer of that Satoshi, I think the inefficiencies could come from the fact that you have to, every time you transfer, you have to do an inscription. So there's like that process versus just transferring the Satoshi. But I wouldn't know specifically the criticisms, but that's my only guess, my best guess. Yeah.
So am I right that you're saying basically if I transfer the Satoshi and it has some like ordinal there, then it's also transferred to the person. So if basically it sounds like tokenization a little bit, basically BRC20. And as you mentioned, like it's kind of interesting solution, but it gets a little bit complicated in terms of, does it really change the price of Satoshi itself? I mean, if you transfer Satoshi, but it has like a, token which worth more, it sounds like Satoshis are no longer fungible. They're kind of non-fungible because one Satoshi would be not equal to another one. So just curious to hear your thoughts about this.
Yeah, great question, and kind of ended with that. For me, it's a gray area, but it's a great gray area because, like say if you're reporting on the use of Bitcoin and that Satoshi is no longer being purposed for the value of that Bitcoin, but instead it's art or some denomination of a token. The question then becomes, what do you report to, say, like the IRS? Like, did you transfer that? Did you even know that was there? So there's a lot of ambiguity there. But I don't have a direct answer of what the consensus will be on that. But there is a case of, if my charts showed up correctly, I think I could pull up one. There's cases of which the single Satoshis are being bought for, millibits worth of Bitcoin, right? So the value of that single Satoshi, is it one Satoshi or is it that amount of millibits, right? Which is, a lot more than one Satoshi. So yeah, that's just right there, without even going into tokens, is kind of calling into question the value of the state on chain. So yeah.
Any other questions for Sam? Yeah. All right. Got one? All right.
This is fascinating ordinal theory. Thanks, by the way, for giving us this breakdown. To my best of my knowledge, you cannot have a one Satoshi output. Is that correct?
Correct.
So is it possible to somehow have ordinals sitting in your wallet, but because of the adjacency of them, you can't send only one of them out? You'll end up having to send multiple ordinals?
That's true. I didn't go into detail on that specific case where, say, the amount that you want to send, the number of Satoshis, the single ordinal, it's obviously less than the dust limit, right? So the way around that is a bit of a multiple transaction shuffle in which you send to a certain output so that way you get the right Satoshis there. You send your input, let's say, has all together 1,000 Satoshis, right? Or 100,000 Satoshis, right? And then you send out, okay, this is one output that is the part I don't care about, and in the center there's the part I do care about, which has the Satoshi, and then the last bit is the part I don't care about, right? Now I can send that middle part to someone else out that has enough, and it has the first Satoshi, and kind of assign things and do things that way.
I'm guessing that half a page of code. Does that
that was quite a bit. I don't want to go into.
Did that actually include that logic? That
No, that logic was more about the way in which ordinals are assigned to each Satoshi.
Oh, okay, got it.
That was the algorithm by which
discovery.
Every block was assigning an ordinal.
Okay, cool. Yeah. Thanks.
Yeah. Any other questions?
One more question? All right. I was thinking we might do a lightning round. All right.
Cool.
Awesome.
Well, all right. Thanks, everybody.
Thanks to our speakers. All right. I'd like to do a quick lightning round. If anyone has anything that they are working on that they'd like to share, if you have a company, maybe you're hiring, if you're starting a group, even if it's not crypto related, I'd like to maybe get people lined up over here. And then you get about 60 seconds to chat about what you're doing. 60 seconds, we'll kick you off after 60 seconds. So 60 seconds max. We'll do, if anyone has anything. Anyone want to chat? What are you up to? I mean, there's so many people in here. I'd like to, come on. All right, we got our first contestant. Can someone start the clock?
It's gonna be pretty quick. I am part of another meetup group called Shared Cost Sailing San Diego. I like boats. I sail boats a lot. I would love to do a crypto cruise with some of you folks. It's generally speaking about $65 a person, 40-foot yacht, 10 people max. Sorry, I can only take one boat because I'm only one person, and I can't. The biggest boat they got is 40 feet. So, but if anyone's interested in that kind of thing, come see me, and maybe we'll set it up. 10 people max on the, well, technically 12 people max Coast Guard, but like it's more comfortable with 10 because there's some, you know, pulling on lines and stuff. We don't want anyone getting elbowed in the face. Whenever. I regularly do this every second Saturday of the month with just randos from the internet, but I would love to do one with the crypto crowd and have everyone like, you know, chip in via Zcash, you know, or pay in crypto. Yeah. Yeah. Yeah, I mean, as long as it doesn't sink, put it in a floating wallet. Write it on foam, not paper. Yeah.
Awesome. $65 a person. We've got 11 open slots. September 9th. All right. We will organize this. I know someone who likes to organize events. So we'll get that organized. All right. Anyone else want to chat about what they're doing? Nobody's doing anything. All right, come on up.
Thank you. I'm Dan McCrary. Just curious, anybody else out here on Nostr these days? All right. I'd like to connect with the Nostr people and encourage all the rest of you to get on Nostr. It's decentralized. Initially, it looks like social media, but it's pretty much going to be the Web3 thing that takes over the world because you can't be canceled. Okay. What else? There was something else. I'll chat up anybody about theology, okay, about Christianity. I do a lot of writing. There was one other thing, but it slipped my mind, but nice to be here with you all. Thank you.
Awesome. Thank you. Anyone else want to chat about what they're working on?
Madison's got so good she doesn't even need me on stage anymore. So I'm here to talk about the California legislation. I've done some volunteering in that space in the past and did some testimony and gone to Sacramento a couple times this year. I haven't been recently. I actually just got back from Toronto from the Futurist Conference. Shout out to my Toronto people. Toronto was awesome. If you haven't been, I highly suggest going. They only have 2 seasons, though, in Toronto. They have winter and construction. That's what they told me. Because in summertime, that's the only time they have to work. So, and it's growing. It's a really great city, very diverse, lots of great food, and very, very crypto-friendly. But back to California, the other CA. The California legislation has 2 main bills that I've been looking at. One is AB 39. This is the California bit license. This made it through the Assembly the first time, and it went through the Senate, and it's in appropriations, which means that's a group of people that figure out whether or not it's feasible to operate this new bill or this law, if they can functionally have the costs from the government to run it. So that's where it's at right now. It's highly likely that all the lobbyist type people are telling the trade organization people are saying that it's probably going to get passed. It's not that great of a bill, and it really is I think it's gonna be really great for the big players like the Coinbases of the world, the Krakens, the ones who already have licenses all over the place. But it's gonna make it really difficult for folks, the smaller folks, to stay involved, and that's sad because with this type of a community, and we talk about decentralization and how it's open, if we're shutting out all the small people and the individuals, it's like the mom and pop shops, right? If we're shutting down all the mom and pop shops and we're only shopping at Walmart, it's not good for America. And in this industry, it's not good for the globe, right? If we're shutting down all the smaller vendors. And so in California, I think this is going to be a really bad thing for the smaller operator. Now, the second thing that goes along with that is the kiosk bill. There's a kiosk bill out there that is basically going to hamper the entire crypto Bitcoin ATM industry in the state of California. It's only going to allow a $1,000 transaction at a time and a max of 10%. And this is the edited version. It was $1,000 and 2%. So they've made some changes, but not enough changes. And so I think that's also going to drive consolidation and people out of the state. Though it's really sad that they've taken such a long time to make decisions and an approach that they're at the cusp of kind of really clamping down too hard. And I'm hoping that either the governor's office vetoes both of these, which is highly unlikely because the pro tem is the one who's sponsored on both, or one of them, and then the Senate financing chair is the sponsor on both of them. So there's a very good chance that these things are going to get passed. And I'll just try to keep you guys updated and let you guys know for the next meetup what happens. But question. That's the thing. I'm not sure that there's anything really that we can do about it, right? We can try to get things amended once they've been passed, but once they're passed, there's not too much that we can do. Now that the kiosk bill would go into effect rather quickly. The actual California bit license wouldn't take effect until January of 2025, so we'd have a whole year, which just basically means people are just gonna get ready to exit, right, or be acquired in that time period, unless they can actually comply with it. And it just depends on the type or the size of your business, but again, the small operators are gonna have to shut down most likely. So sorry for the unfun note about legislation, but when is politics and legislation ever fun, right? So yeah, another question. Yeah. Yeah, no, I think I appreciate that suggestion. The suggestion was that we should set up some sort of document or, get signatures to show that we're not thrilled about the laws that they're passing, which is one way we can go about doing it. So we'll see. It's a good idea. I'll think about setting something up, and if I'll talk to some of those lobbyist groups and trade organizations to see if they think it's even worth doing at this point, because they're the ones that are on the ground. But let's get to that raffle.
That's what I was thinking. Chris gets over 60 seconds because he's a co-organizer. So shout out to our co-organizers. Thank you, Chris, for doing all the things that we don't have time to pay attention to. All right, we're giving away 7 ZEC, which I think 1 ZEC is around $26 US right now. I think at its height, it was definitely over 100. So, yeah. Chris, I'm going to actually have you come back up here. I got a Tupperware box from Bantai. The best place ever. I'm going to have Chris reach into here and pull one out. We're going to do one winner. One winner. One winner.
No pressure for me, right? This is why I didn't get a ticket, because she was going to make me pick. Here's one that's flat on the bottom. Oh, okay, here we go. The number is H01. Oh, sorry, it's 104. The number is 104. Hey! Zero knowledge proof. I love it.
I didn't set up
the wallet. I feel guilty. Like I wasn't sure. I was pretty sure I'm not gonna win.
All right. Well, I've got your
But
contact.
that's because I was listening very patiently to.
Oh,
everyone.
yes, yes, yes.
I just
Awesome.
didn't want to be distracted.
Well, we have, I'm sure we have some leftover pizza. We've got drinks. Let's give it up one more time for our speakers. And shout out to our sponsors. This is possible because of them. So thank you so much. Bitrefill, Edge, Coinstructive, Zcash. Oh, next meetup we do not have booked yet, but I've got Kurt. He's chatting with some people. Definitely September. I'm also trying to plan another pub crawl. So last year we did a POAP pub crawl where at each bar you got a different POAP NFT, and we pulled together all of the crypto meetup groups in San Diego, and so I'm really trying to make one of those happen before the end of the year. So look out for a POAP pub crawl, and then we'll post another meetup next month. I did want to mention there's 2 crypto conferences coming up in this area. So one of them is Breathe. It's in Vegas, but it's going to be, I believe it's the 11th through 13th of September. After that, there's a Hive Fest that's happening in Rosarito, September 22nd through the 26th. So they're not like in San Diego, but they're crypto conferences that are semi-local. We've got Vegas and Rosarito. Pacific Bitcoin Conference in Santa Monica. When is that one? October 5th and 6th. Awesome. So that's awesome. Thanks, Kurt.
Where to monitor this? Because I just checked that on Telegram group you didn't post this one, so probably there's another place.
Yeah, so we try and keep all of the Edge events. If you go to edge.app, which is our website, there's an events page. So every single event that we are hosting in the event space that you guys are in right now are going to be on the events page. We do have a Telegram channel. We all, as a community, need to work together to be more active in there, myself included. So yeah, we'll try and be more active in there. Yep, yeah, we can post it in there. Yep, Bitcoin and Open Blockchain San Diego. We can, if you're not in the Telegram group, we can get you added and we can work on being more active in there. So awesome. Thank you so much, everybody. Yeah, if you would love to be a super helpful volunteer, we stack the chairs right over there. Thanks, Kurt. Yeah.